Okay, just a quick overview of polynomials and their degrees and their x-intercepts. So we have these two equations here, which are both polynomial functions. And if we want to talk about the degree of each equation, we want to consider the form of the equation. So if we look at number 1 here, we have x cubed minus 2x squared plus 4x minus 7. If we look at number 2, it's in a different form. We have a bunch of parentheses, x minus 3 in parentheses, x plus 4, x minus 5. So the top form is what we would refer to as standard form. And the bottom form is what we would refer to as factored form. So there are 3 factors in the bottom form, x minus 3, x plus 4, x minus 5. And those 3 factors tell us how many degrees are in the polynomial. 3. And so we have, because we're going to have x times x, which will end up being x cubed. Now, if we look at the standard form, what we want to do when it's not written as a bunch of factors is we just look for the term with the highest degree, which is usually the first term, not always though. So when we look at this, we see x cubed is x to the 3rd power. This is also a polynomial of degree 3. So both of these equations, even though they look different, both have a degree of 3. And what that means is if you're going to graph it, kind of running out of room here, but I'll do a little graph, that it's going to have 3 different directions in the graph. So these are going to have different graphs, but true of both of them is that they're going to go up, down, and then up again. Where they cross the x-axis and how high and low the turns are is going to vary, but the general shape is that they're going to go up, down, and then back up. So 3 direction changes, or in a lesson it talks about 2 turns. So there's a turn here and a turn here. So the number of turns is usually 1 less than the number of the degrees. Let's talk more specifically about the second equation in factored form. The other thing that we can get about polynomials in factored form is where their x-intercepts are. So just like when we solve equations for the factors, we set them equal to 0. And then that tells us about what the solutions are. And when we set each of these equal to 0, like x plus 4 equals 0, if we solve it for x, we would actually get minus 4. Sorry, that's an x. So one x-intercept is negative 4. If we look at this x-intercept, you can probably make the guess that it's x equals 3. And the third one is going to be x equals 5. So if we wanted to graph this equation, we could be more accurate. We know we have an x-intercept at negative 4. And then we have an x-intercept at 3. Whoops, that's a dot, and an x-intercept at 5. And then that we can be even more specific in the shape of our graph of where, whoops, I don't mean to do that, of where it crosses through. It's going to hit those points. Whoops, I missed kind of, but it's going to hit that point and that point. And so that's also a 3rd degree polynomial graph. The last thing the lesson talked about is if you have a graph, it's like figuring out how many degrees there are. There are 2 ways you can do it. The lesson talks about the number of turns. So if we look at the number of turns, we make a turn here, 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 and here. And the number of turns is 1 less than the number of degrees. So the number of turns is 4, which means the number of degrees is 5. I liked, because I don't like to remember if it's 1 more or 1 less, I like to just think about the number of directions. So we go up first, and then we go down, and then we go up, and then we go down, and then we go up again. And so if you count those different directions, up, down, up, that's 5. And that's also the number of degrees. So you can think about it as turns being 1 less than the number of degrees or directions being equal to the number of degrees. I hope that was helpful.